We're going to look at logarithms and logarithmic functions today. Here we have the definition of a logarithm basically. You are going to need to know this for the sake of this test and the final. If you don't know what's boxed in here, there's no way you'll pass your test. There's two different ways to write the exact same thing. X equaling b to a power can be written and mean the same thing as log base b of x equaling a. It's also important to note that b has to be positive. And that x has to be positive. In other words, you may want to write down that whatever is after your logarithm, the x, has to be a positive number. So let's go ahead and take a look at these. Let's rewrite these from the logarithmic form to the exponential form. The easiest way to do it is to basically take your base of the 8, in this case, swing it over, and it's going to hit the 2 up as an exponent. And so you get an 8 squared equaling 64. Two different ways to write the same thing, because what your log base 8 of 64 means is 8 to what power is 64. Same idea over here. You're going to take your 16, swing it over, and it hits the 1/2 up as an exponent. And when you do that, the log drops. Because that's really what we're doing up here, is we're taking our base, swinging it over, and it hits the up as an exponent, and that's how we are getting this. So we'll do that on the next one. Take your q, swing it over, it's going to hit the t up as an exponent, and we get this. On this one here, you're going to have to swing your base of an x plus 2 over, and then it's going to hit your s plus t up as an exponent. But since there's more than one thing here as a base, it's not just a single item, it's an x plus 2, you need to have your x plus 2 in parentheses so that your exponent of the s plus t applies to the whole base. So here we're going to be doing the reverse form. We're starting out with a logarithmic equation, exponential equation, and we want to write it in the logarithmic form. So in other words, back here, instead of going from this form to this form, you're going to start out with the exponential form here to go and rewrite it over here in the logarithmic form. To do that, you want to go log of your base. Your base is this right here. Your exponent, which is the 1/3 right here, goes on the other side all by itself. What was on the other side all by itself goes after the base. So we get log base 27 of 3 equaling 1/3. Same approach over here. We'll go log of your base, and your base is always the thing that your exponent is on. Then we'll go equals. What was on the other side all by itself goes after your log. The exponent right here goes on the other side. And so then we get log base 10 of 100 equaling 2. Using the same approach down here, go log of your base, put the exponent on the other side, and then what was on the other side goes after your base. Same approach here, we'll go log of your base, your exponent goes on the other side, and what was over there goes after your base. So we need to evaluate these, and we're going to evaluate these without a calculator. We need to think about what this means. This means 10, because that's your base, to what power equals 1,000? Well, you should realize that 10 to the third power is 1,000, so your answer is 3. So for each one of these, you want to think about what it means and then try to answer the question. So here we're dealing with 2 to the what power is 8. Hopefully you remember that 2 cubed is 8, so we end up getting 3. This is 9 to the what power is 8. So it's always your base, the subscript here, to what power is this number right here of 3. So 9 to what power is 3. And that is 1/2. You should remember that it is 1/2 since 1/2 power means the square root. And the square root of 9, or 9 to the 1/2, is 3. This one here means 8 to the what power is -5. There is no such thing that works, so it's impossible. There's no solution. You can also remember that whatever is after your log, we said before, has to be positive. This one over here, 8 to what power is 1? And you should remember to get 1 out, you need to have your power being 0. Here we have a log on the left, a log on the right, with the same base. So therefore, what's after your bases, the x and the 7, also have to be equal, even if they don't have the log stuff there. And then that also works with inequalities. This log base 5 of x is greater than log base 5 of 7. Same base, single log on each side, so therefore what's afterwards has to follow the same as here, your inequality. So this right now is in logarithmic form. Let's go ahead and write it in exponential form. So that means we got to take our base of 8 and swing it over. And when you do that, your logarithm drops. Now you got to think, okay, the denominator of the exponent is 3. So that tells me to take the cube root. The cube root of 8 is 2. Still have to raise it to the 4th power. 2 to the 4th is 16. Since we started out with a log, we got to check. Does our 16 cause what's after our log to be positive? And yes. Same idea over here. There's nothing more we can do in this form, so we have to rewrite it in the other form, the exponential form. So we'll take our 27, swing it over, hits our 2/3 up as an exponent. 2/3 as an exponent means you got to take the cube root of 27, which is 3, and then you got to still deal with the numerator of the exponent, which is the squaring, and so we get 9. And it also works when you're dealing with inequalities. So we're going to take our 6, swing it over, hit the 3 up as an exponent. But keep in mind, your inequality always is going to be pointing, or with your base here, our, not our base, what's after our log, which is x. The big part of the inequality is going with that. So down here at the big part still needs to be hanging out by the x. So we get x to be greater than 216. Over here, we need to write it in exponential form. We're going to take our 3 and hit it up. Notice our x right here, what's after the base, has a small part pointing towards it. So we need to write our answer that way. So we get x has to be less than or equal to, or I mean not equal to, just less than 9. However, keep in mind, we said that what's after your base, or your log, like your x, has to be positive. The 3 is positive. We've got to make sure the x is positive. So to make sure that x is positive, we need to make sure we say that x is greater than 0. So we're really looking for numbers that are greater than 0 and less than 9. To write greater than 0 and less than 9 at the same time, we're looking for numbers between 0 and 9. We would write it as 0 less than x is less than 9.